Hello Internet, my name is Quinn and this is Blondihacks. Continuing on the smokebox frame assembly now at the front of the locomotive, we're going to finish that up and get on to some of the internals of it. So let's go. Picking up where we left off then with the smokestack bushing that goes in the top of the smokebox, we can get busy with the rest of the smokebox shell now. Of course, we need a hole in the smokebox for the smokestack to pass through and seat into this bushing, and we need a bunch of other holes as well, so it's time for this rotary table setup on my milling machine that I use for large rotary setups, boiler shells, and similar types of things. This smokebox is essentially a small boiler shell, so I'm going to treat it the same way, and this setup works really well for that. I can unlock the worm drive on this Vertex rotary table, which makes it a lot easier to dial it in. This is, of course, a hammer-formed copper cylinder, so dialing it in is somewhat of an academic exercise. It's a bit of a cargo cult of dialing in, but I got it within 0.008, I think, which is certainly sufficient. As long as it's not so far out that the moose can tell, then it'll be fine. Now for a trick I got from another model engineer on YouTube. I'm sorry, I forget who. I think it might have been Myford Boy, and that's to put another block of wood between the two end plugs when using hardwood end plugs like this to support a tube, and that allows you to put some pressure on the outer plug with a tailstock on your lathe, or in this case the footstock on my mill, and get a much better grip. Otherwise, of course, the wooden plug will just get pushed in by the pressure of the tailstock and you won't actually get support. Then I give it a quick 360 to make sure nothing crazy happens, and that looks pretty good, so let's make some holes. The next job is to get it aligned with the y-axis. There's a scribe line down the center line at the top of the smokebox, which you can't see. That's one of the lines that we put on it before rolling the material, and it's now our top center line reference. The job here is twofold. I need to get it centered on the y-axis, but also the line has to be at the topmost part of the curve when the shell is at 0 on the y-axis. Getting the shell centered on Y is easy enough with the help of a straight edge and a measuring stick of some sort. And then sometimes you have to then also rotate the shell a little bit in the jaws of the rotary table, or as I did in this case, rotate the rotary table until that line is facing upwards when on the y-axis 0, and then add whatever degree offset you end up with to all your measurements, since you can't zero the scale on a rotary table. The smokebox hole is a big one, so I'm going to spot the location with the center drill here, and then I'm going to rough in the dimension with a step drill. This is a great application for step drills because it's pretty thin material and we need a large diameter hole, and the downward tool pressure of step drills is very low. They mainly cut horizontally, rather like the corner of an end mill, and they also do quite a nice job. The downside to step drills, and the reason I don't use them more, is because you need a lot of clearance underneath them. They have to stick down into the material very far to get to the diameter that you need. However, for a boiler shell, that's almost never a problem. Although, amusingly, I did actually end up drilling into that center support block of wood a little bit, but of course that's harmless. Once I'm close to final dimension, I'll come in with the boring head and finish it up. The boring head will allow me to hit the dimension exactly, and I can also make sure the hole is nice and round. If the step drill wandered a little bit, or there was any vibration or anything, it might make a hole that's a little bit oversized or a little bit out of round, that sort of thing. And just like on the lathe, a single point boring tool will correct all geometry errors caused by multi-point cutters. Once I'm happy with that dimension, then I can move on. While I'm here in this setup, I might as well do a few other holes that will be needed in the smokebox. There's some mounting holes for the handrails that will eventually be on the outside of the boiler, and there's a couple of fixturing holes for various attachments around the shell and so on. I'll zip through this because it's not very exciting. Now, what is exciting, however, is we need to put a giant rectangular hole in the bottom of this thing. And I'm going to rough this in by chain drilling with the step drill again. I don't think chain drilling with a step drill is something I've done before, but it felt like the right move here. Because this is a big rectangular hole, the step drill is going to get rid of most of that material, and then I'll come in with an end mill and mill it out to the rectangular shape that we need. What goes in here is kind of like another boiler bushing, but it's a big rectangular bulkhead fitting that the steam goes up and down through the bottom of the smokebox. So the steam from the boiler goes down through one of these holes into the cylinders, and then the exhaust that's coming out of the cylinders comes back up through the other hole. And if you remember from the previous video in this series, you know that that exhaust steam goes into an exhaust jet that is then fired up into the petticoat pipe, hopefully with consent. I'm doing this in lots of light passes, really taking my time with this because machining copper is very much like owning a pet tiger. You can read all the books and take all the precautions, do all the things you're supposed to do, and it will purr at you and love you and sleep in your bed, and then one day, with no warning and for no reason whatsoever, it eats you. That's looking good. That came in a tiny scooch under size, but that's okay. We can do a little bit of filing for a perfect fit once we've made the mating part. This tends to happen with copper. It has a lot of spring back in it, and also when you're measuring the dimensions by doing math on end mill diameter, sometimes you end up undersized because of end mill deflection, but that's not a problem. We can adjust that later. Now, back to the top, let's get on to fitting the actual smokestack ring into place. I need some fixturing holes to screw this into place for soldering, and I decided to try and do that with some clamps. I made this plug over on the lathe to keep things aligned, and then I thought if I can get a clamp in there and hold the ring in place while the plug is aligning everything, but there was no way to get a clamp in there, unfortunately. So plan B, I put a machinist jack under the shell and then one in the shell with a sacrificial block on top of it, and I'll hold the bushing up from underneath, again with the plug holding everything in alignment, and then I can drill down through both parts with my tap drill size right into the sacrificial block that's on top of the jack. And that seemed to work fine. Then I threaded through the entire mess while I was still in this setup before anything has moved, and then I pulled out the part and clearance drilled out the threads that are in the top shell. Now I can bolt that into place and make sure that's all gonna be properly fixtured for soldering. These screws are over length, of course. I'll cut them down later, but that is looking really good. Those screws are holding that perfectly aligned, so we can move on. In the previous video, you may recall I made the two rivet straps as one long one with the intention of cutting through both of them when I make the rectangular hole, and that has gone exactly to plan, I'm pleased to say. I ended up with two small strips exactly where the drawing says they're supposed to be. So I think that was a good way to go. Let's now make the rectangular bulkhead fitting that goes in that hole. I'm going to use this chunk of brass, and I'm going to do what I call to myself a CNC setup, which is where you do the entire part in one setup, kind of top down and outside in. So I've got the part set up like this with enough material sticking up to do the entire part. Then I face the top of it, zero the quill DRO there because I now know where the top of it is, and I can feed down a little bit more than the total height of the part and do a cut all the way around the outside. What's nice about this is you don't have to do any measuring or edge finding because you know the diameter of the end mill, so you touch off on one side, clean it up, then move to the other side, the dimension that you need plus the diameter of the end mill, and machine that, and now your width is going to be perfect. And then you can do the same thing on the ends. And after doing a pair of sides like this, you can do the half function on your DRO just like you would with an edge finder, and you already have your center line as well. So again, no measuring, no edge finding. I call this a CNC setup because it is how you tend to set up parts on a CNC machine. You set them up such that the entire thing can be hewn from one block in a single setup. It's not often that on a manual mill you have a part where all of the features can be arranged in such a way to do them from one setup like this, but in this case we can, so I'll take advantage. And as I said, while I'm here, I can also do the holes in the center all in one setup. The limitation of this method of making parts is that you have to have a fair bit of excess material on the underside of it, and for brass, on a small part like this, that's fine. But I tend not to use setups like this in steel because when you're done, you got to flip the part over and mill away all that extra material. You have to have a fair amount of it so you have a good grip on the part, and it can take a while on hobby mills to mill away that much excess material. The other thing you have to watch is when you flip it over to mill off that excess, if the top and bottom of it need to be perfectly parallel, you're really going to want to indicate in that bottom surface or have the bottom surface sitting on parallels rather than kind of floating in the vice jaws as I've got here on some shoulders that may or may not be well seated in a parallel way on those vice jaws, and you can't compensate for jaw lift in a setup like this unless you have parallels underneath. In this case, it's going to be fine. This is not a high precision part, but something to be aware of if you're trying to create, for example, a rectangular shape where you want all the surfaces opposite to be perfectly parallel. But otherwise, just mill down to the desired final thickness and you are done. That came out really nice. Excellent looking part. Sometimes the simplest ones are the prettiest. So it's got kind of a T-nut shape to it because it goes in like this, and that flange keeps it from pushing up through the hole. However, of course, it won't go in the hole right now because the corners are round from the end mill. So a little bit of filing. I use a triangular file for this, not a square file like you might think. Using a triangular file gives you better control because you can do one side of the corner at a time rather than a square file, which is going to be modifying both surfaces at the same time, and you're much more likely to end up with a cattywampus corner. I also did a little bit of filing on the edges because, as I said earlier, this hole was a little bit undersized. But now that is perfect. Look at that. Oh, the only thing better than a perfect fit in machining is a perfect fit that you hand filed. That is incredibly satisfying. If we look at it from underneath, you can see how that nestles in nicely between the rivet straps there. I'm here for it. All right, test fit time. Let's see if I can fit it on here. So the bulkhead goes on top of the steam tee, as you can see there. And then the smoke box should go on the end of the boiler. And that bulkhead fitting should slide right into the hole on the underside of the smoke box. If I did everything right, and well, I didn't, because look at that. As you can see, it does not fit, and it looks like it's out by about 330 seconds. And, you know, it's hard to say where this kind of error is coming from. There are, at this point, where we're assembling large sections of the locomotive that have never seen each other before, there's so many sources of error. To use a software metaphor, we're kind of at integration level systems testing now. And so we're seeing bugs, if you will, that we wouldn't have seen in any other way until we start bringing all of these subsystems together. So this error could be, or is likely coming from multiple places. The steam tee is probably out a little bit. The length of the boiler is probably out a little bit. The position of the boiler longitudinally is probably out a little bit. And well, now I just have to kind of look for ways that I can reduce those errors in other possible places. The longitudinal position of the boiler is definitely one. I did some measurements and found the boiler is sitting quite a bit too far forward because it's sitting on some stay bolts that are resting on the rear bolster. So as much as I hate to take a file to my finished and pressure tested boiler, it was really the right thing to do. Those stay bolt heads were sticking out way more than they're supposed to. So I filed those down no more than I dared because I'm not about to start creating leaks. I didn't want to get into the actual silver solder fillet, but I was able to steal a 30-second from there, but from this point I kind of ran out of options. I didn't really have anywhere else that I could find some dimension, and so I kind of took the coward's way out and I slotted out the holes in the bulkhead fitting. It's a bit ugly, but that gave me the extra that I needed. As a nice side benefit, this actually allowed me to give the boiler a little more breathing room as well. The boiler does expand when it heats up, of course, and so it actually slides back and forth a little bit in the frame, and you need to make accommodations for that. I'm not sure where in Kozo's design he intends that expansion to happen. I suspect he intends it at the firebox end because there are no hard attachment points there, and there does seem to be extra space in the frame there in the drawings. So I made sure to try and give myself extra space in that area as well. I also considered moving the rectangular hole a little bit, like I could file some extra clearance on one end or the other, but I figured that was a bit more of an uglier change. And also, in principle, the smoke box needs to be somewhat airtight, like not perfectly, but the more airtight it is, the better draft you can get from the blower and the exhaust jet. So if I need to, I can fill those slotted holes with some sealant, and that's an easy way to regain the airtightness that's been lost by slotting them. Whereas if I slot out the entire hole in the smoke box shell, that's a lot harder to plug up. Next, I want to make sure that the smokestack is going to be sitting vertically because that was the point of this whole exercise. If you recall, I deferred working on the mounting tabs because I needed a source of vertical truth, and that all looks really good. Sorry, the camera is crooked here, but I put the alignment plug in there to give me something to eyeball. In post, I straightened this frame so that you can see that the smokestack looks like it's running vertically relative to the locomotive itself. So I'm very pleased with that. I think we succeeded in making a smokestack that's vertical, and now you can see the fittings on the tube sheet on the boiler are crooked relative to everything else. For the camera nerds out there, I do actually have a level indicator on my camera and on the tripod, but the tripod mount that I use has a lot of slop in it. It's one of those quick release things, so it's very difficult to get the camera perfectly level, even with all those tools. But I kind of like a little Dutch angle in my footage, so I've never bothered to fix it. Now off camera, I made a couple of mounting bosses. These are for the smokebox door. We'll get those soldered on. And I soldered in the smokebox mounting ring. This was done upside down so that the solder will nicely kind of nestle into the concave surface. That was an easy job because it was fixtured in place. Now flip it over and we're going to do that bulkhead fitting. And this has to be done this way because of, again, that flange holding it in place. It'll fall out if I do it the other way. However, doing it this way means we're soldering on a convex surface, which is difficult because the solder wants to just run off the surface and not settle into the joint. So you will notice some white goop around the part. And this is a trick that I know a lot of other model engineers use, and I know a number of you folks have also suggested it, but it's not something I have tried before. So I'm trying it here, and that is to use whiteout as a mask or a fence to contain the silver solder. I believe the theory of operation there is that whiteout is a very simple product. It's just titanium dioxide in an acetone solvent. So the acetone flashes off, and what's left behind is a mineral, essentially. The titanium dioxide is very immune to the heat, and the silver solder won't roll past it for whatever reason. It's just like a physical barrier for the silver solder running through it, and it'll stay there and contain the solder. Because the white pigment in it is just a mineral, it won't flash or burn off like a lot of other things that you might paint on there would. I've also seen people use white acrylic paint for this. I believe Myford Boy uses that. And white acrylic paint is essentially the same as whiteout. The solvent or the binder is different, but the pigment is, again, titanium dioxide, so same effect. Here's that joint cleaned up now, and you can see this kind of wavy line along the edge of the solder there. And that, in fact, is the edge of the whiteout. I was very sloppy in my whiteout application, so I've learned to be better at that next time. The pickling acid, though, had no trouble removing the remains of it. There's a little bit of crud left there that wipes off easily, but that's really cool. You can actually see the outline of the whiteout in this oversolder. So that worked perfectly. I'm a believer, and I will be doing that in the future for sure. This is what I use, just basic off-the-shelf whiteout. I think all the brands are the same. They're all just a solvent with titanium dioxide. Then I went ahead and did those mounting bosses for the smokebox door that's going to go on the front. Those will get drilled and tapped later. I filed all of the various mounting fixturing screws off. And that's almost it now for all of the attachments that go on the smokebox shell. So all these attachments are all perfectly square and plumb to each other because they were all arranged on the rotary table setup. So I know that these are all valid sources of truth. So now I can move on to doing the mounting brackets for the boiler, which of course need to be crooked, and I'm going to determine those procedurally from the boiler itself so that they are guaranteed to end up at the correct incorrect angle. So I'm going to make them out of this copper bar. I'm going to anneal these because we need to make some L-shaped tabs out of these, some brackets. These might be easier to just machine out of a block of brass, but the drawing calls for bent copper tabs, and I thought it would be an interesting little exercise to try and make them out of bent copper like this, so that's what I decided to do. I do think machining them out of a block would be quicker, but this was fun anyway. Good practice for sheet metal work, which I definitely need practice at. I opted to hammer form the L bend because that allowed me to get a very nice, crisp, sharp bend, much better than any kind of bending brake or other bending method with pliers would have done. Then I measured the distance in from the inside shell of where the position is going to need to be for the hole. The two holes need to be the correct distance apart on the shell, but once they're the correct distance apart, then we can move the brackets around as needed to make them fit. I left myself lots of extra material on both sides of the bend just in case, so now I can saw off the excess. I filmed myself doing this with a fret saw so I look like a real model engineer, then got sick of that and took it to the bandsaw. Here comes the tricky part. These brackets need to be silver soldered perfectly in place in their correct positions so that this thing will mount to the boiler. And this is the method I came up with for doing this. I bolted them both up onto the boiler, and you can see how the flat sides of them there, that's where they're going to need to get soldered to the shell. Now, obviously it's a round surface, but the brackets are short enough on the vertical dimension that the solder can fill that. I don't need to do any kind of curved surface on the inside of it. Then, with those in position, I scribed the outline of where those brackets are going to end up when they're in the correct position. This doesn't have to be perfect because this outline that I'm scribing is just a box to give me a target to put a clearance hole in the outside of the shell through which the fixturing screw is going to go for soldering. So you can see I just needed a hole to land somewhere in that rectangle, and now I can use a fixturing screw to hold it for silver soldering. Now to transfer that screw into the exact right place on the bracket, I attach the bracket to the boiler first, tighten it down, then I fit the smoke box on there. Then using a scribe the same diameter as the clearance hole, I transfer the center of that clearance hole onto the side of the bracket. It doesn't matter where that lands because it's just a fixturing screw that's going to get filed off after soldering. It just has to land somewhere on that bracket. Now I can drill and tap that position on the mill. Then I clamped it all back together, and this time everything's covered in flux. So I've got everything bolted in final position. Then I put the fixturing screw in the side, and again, everything's been fluxed so that I can carefully take the boiler mounting bolt out, slide the whole thing out without moving that bracket, bring it over to the hearth, and silver solder it in place right where it is. In principle then, the fit up should be perfect when I'm done, as long as it didn't move between taking it off of the boiler and moving it over here to solder it, and the fixturing screw should prevent that. But in principle now, the boiler has told me exactly where it wants that bracket to be, and I didn't have to measure anything or try to do some tricky transfer punching or anything inside the smoke box. I did that for both of those brackets, and now, moment of truth, let's see if it actually bolts up and is sitting straight. Fortunately, I wasn't too stressed by this process because there is a plan B, which is to simply enlarge the clearance holes in those brackets if needed. The bulkhead fitting is doing the primary orientation of the smoke box. These brackets are just holding it. They're just clamping it to the boiler. But I'm pleased to say that worked beautifully. Everything clamped up perfectly. You can see through the smokestack hole what those brackets are doing. They're clamping it backwards to the boiler itself. Then looking head on again, you can see how the brackets are crooked 2.5 degrees, just like the mounting bosses on the boiler are, but the smoke box is now sitting straight. So we've negated the error that was in the boiler, and I gotta say that process was very intricate, but it worked really well. I ended up with a smoke box that seems to be perfectly aligned. I gotta say, that really looks like a locomotive now, eh? Look at that. I mean, it also looks like a giant Duracell battery, but shut up, it's getting painted, okay? I was pleasantly surprised how many steam engine points it gained by bolting that onto the front of it. It doesn't just look like a weird thing sitting on a steam engine frame anymore. It actually looks like the beginnings of a locomotive, if you will. There's a lot of tricky parts in there. This is one of those assemblies where it was worth really taking my time, going slow, triple checking everything to make sure that all the seams landed perfectly and so on, and I'm very, very pleased with that. Now here's a side shot so you can see it. Now I've actually got it shimmed up in the front there a little bit because the steam tee does not actually hold up the front of the boiler. There's a big saddle that goes underneath it. And until that is in there, the front of the boiler would sit a little bit low. It would look crooked in this photo. So I've shimmed it up a bit so you can see what it's supposed to look like with the boiler level. Here's a wider family shot. It's been a while since we've seen the entire thing. It's actually getting difficult to photograph it on my little workbench. It's getting too big, which is a good problem to have. That means we're making good progress. I'm really excited with how this turned out. It's a very intricate sheet metal assembly, the kind of thing that I'm frankly not very good at, but I'm slowly getting better at, gaining some confidence, and I'm really happy with how that came out. Well, now we got to build all the stuff that goes in and around the smokebox shell. Thank you so much for watching. Thanks to my patrons for making all this happen, and I'll see you next time.